Hello, this is section 4, 20.4, and these are some other functional groups that we looked at in that main poster. So we have aldehydes, ketones, carboxylic acids, and esters. And so if we look on this chart, aldehydes, ketones, carboxylic acids, and esters. Carboxylic acids are super important. We see them a lot in biology for sure. And then we also see like aldehydes. So they're just really common. We're not going to get into these crazy ones, but we'll do the common ones that you'll see a lot, just so you're familiar with them. Carboxylic acids have, not carboxylic acids, carbonyl groups have just a double bonded O. So these are all, aldehydes and ketones are both carbonyl groups. So we're looking at this double bonded O. And then ketones specifically have carbons on either side of that carbon that's double bonded. Aldehydes have an H on one of the sides. So that's the difference between aldehydes and ketones. So there is an aldehyde. So it has an H here instead of another carbon. That's what makes it different from a ketone. Here are some examples. These are cool. This is an aldehyde right here, and it's also an alcohol, and it's an ether here. I hope Erica's not too loud. She's learning with us. So this right here is the aldehyde part. This is the artificial flavor vanillin, and we see this in like artificial vanilla. That's one of the reasons I like organic chemistry. It's cool like that. Cinnamon aldehyde is another fake like cinnamon flavor. And here's the aldehyde at the end. So it's also got a benzene, it's got a double bond, so it makes it an alkene, and then you have a aldehyde. And in all honesty, I would have trouble naming this with using, IUPAC names. So we just have this common name. This one would be tricky to name. And then butyrylaldehyde has this aldehyde. This is not the IUPAC name. This is not how you would name that one. So here's how you would name it. You just name the parent chain, and then instead of you take off the E and replace it with an AL. So with alcohols, we replaced it with an OL. Aldehydes, you replace with an AL. Make sure you're writing neatly. This is our simplest one. If you turn this into an aldehyde by just adding, like if this was our methanol, you just make this a double bonded O, just one O there, and it would be methanal. This one would be ethanal, and this one is chlorobutanol. Our first carbon is the aldehyde carbon. For ketones, we also use the parent name, and then we add ONE for that suffix. We don't have an example. So an example would be like propanone. The smallest one we can have is propanone because, am I right? Ethanone. Yeah, you can't have a double bonded O in the middle of a carbon because you only have two carbons. So the smallest ketone is a propanone. That's how you say that. Butanone, pentanone, etc. Carboxylic acids look like this, and I call these Cu groups. We've seen them in biology and stuff, and I think in chemistry some. So you have a double bonded O and an OH. And just a side note, we are ignoring some lone pairs of electrons. This one has two lone pairs here and here, and this one also has two lone pairs. That's why it has that shape, that bent shape. So just a little side note. That's our general formula for carboxylics. They're weakly acidic, and they're super important. They're in like tons of biological molecules. To name them, name the parent, and then you replace the end with oic. So like benzoic, and then you put acid. Benzoic acid, bromopentanoic acid, chloropropanoic acid. So you add oic acid, and that's what makes it a carboxylic acid. They're just weak acids though. Here's some other simple ones. So if you added a Cu to your methane, it would be methanoic acid. To your ethane, it would be ethanoic acid, propanoic acid, butanoic acid, pentanoic acid. And then these are common names. Acetic acid is vinegar. Formic acid is produced in ants of the genus Formica, and it's like this really smelly odor that they produce. So that's fun. Esters are the next one. Esters have a double bonded O here, and then another O with C's. So it's kind of like a carboxylic acid, but instead of stopping here with H's, they have carbons. That's an example of a reaction. So here you have a carboxylic acid, a COO, reacting with an alcohol, and it's going to make an ester and water. So you have a double bonded O and then an O bonded to other carbons. There it is. So it kind of looks like a COO, kind of looks like a carboxylic acid, but these R's are other carbons. To name them, you, this description, you kind of take how you would name a carboxylic acid and you add O8. So like this is isopropyl ethanoate. So you add O8 to it, not just 8. And that makes an ester. And then here you can see your double bonded O and then your O that's in the middle of more carbon business. Amide is the last one, I think. Amide is kind of like an ester. It has a double bonded O, but then instead of another O, it has an N. So it's kind of a mixture between like an ester and an amine. And I hope that you're picking up all these words and I'm not speaking Greek to you. Wish we could do this in real life. Here are some amides. So again, you have your double bonded O and then your NH2. Amines just have an NH2. So those are some examples: methanamide, ethanamide, propanamide, and butanamide, just depending on how many carbons. And that's how simple we'll keep it. We won't get too hairy. I don't think I have any questions on this on your review, but this is how you make some of them. And you can do like addition reactions, adding two together. You can do elimination reactions, which are splitting them, which are decomposition. And then you can do some single replacement. This looks like your basic single replacement reaction where you're substituting things. And then finally, polymers. We can use these molecules to make polymers like nylon or other ones like plastics, bouncy balls. All of those are polymers. So we can take these small molecules and bond them together like beads in a chain, and eventually you'll get long polymers. So one example is polyethylene. Ethylene is this double bonded Eth group, 2 carbons. If you bond a whole bunch of them together, so there we are, you're going to end up with a whole bunch of these tiled up together, and that's going to make a polymer. So condensation is when we build these. We pop these together. Nylon is a good example. And then once we bond these 2 molecules here, for example, we will get this big molecule and water. Okay, and we can also do 2 different types of polymers. So I could like bond these 2 different kinds together, for example, maybe, and get like interesting polymers. Okay, so that's section 4. I hope you guys are doing well.